All right, first things first. I need to cover something that we talked about a little bit on Thursday, last time we met, but I don't think I did a very good job of making sure you understood. Okay, so let me tell you real quick. Did I tell you, or do you remember? Because I know I said some of it. Do you remember what I said? What kind of log bases we are going to use? 2, 10, and something, right? And see, that's the part I forgot. I forgot the something. Okay, so it might look like this: log of x, which we know has a understood base of 10, even though it's not written, right? Or it might say log base 2 of x, but the other one is log base e of x, but you will never see that. You will never see it written like this, unless it's written by somebody who doesn't have any idea what they're doing. Then you might see it, okay? Because this log base e is written like this. Now it stands for natural log. Now this, why is it ln when it's natural log? Well, it comes from the French for log en naturel, and I completely made that up. I really have no idea why it's ln. Okay? It might be some other words, other languages, but we write ln, but that means natural log. Natural log means log base e. Does that make sense? Yes? Okay, so we'll talk about those bases here in the next couple days, but for now, let's start with log properties. I think when we get through this worksheet today, you're going to realize that you know a lot more about logarithms than you originally thought you did. Okay? Remember back to the last time we met, what did I tell you about Batman and Superman? They can't do the same thing, but they're very alike, right? Okay? I even had my Superman shirt on, right? I have my cape today, right? I have my Superman cape, because I'll wear that this afternoon when I'm talking to my Algebra 2 classes. All right? So let's go ahead and talk about these log properties just in general right now. We'll get a little bit more specific in a moment. But let's choose 3 specific numbers to talk about right now. Okay? Log base 5, log base 10, and log base 100. Or, I don't know why I'm saying base. I'm sorry. Log of 5, log of 50, and log of 100. All right? So it asks us, please evaluate these expressions using a graphing calculator. And just to keep things a little bit easier, we're going to round to the nearest tenth. So in your calculator, you're going to type in log. Now, the cool things about these calculators real quick is I don't have to put in a base. There's not a base on this, is there? So I know it's automatically log base 10, right? Well, guys, the calculator knows that too. If you want to put in log base 10 of 5, it's going to give you the same answer as if you put in log of 5, because look what it did. It filled in the 10. I didn't put the 10 there, did I? Okay? So what is log base 10 of 5? And if we're rounding to the nearest tenth, 0.7. Okay? So in this box, we're going to put 0.7. Yes, ma'am. Uh-huh.
I tried to leave out the base and it wouldn't work.
Okay.
It was like the same task.
I don't know. I don't know what to tell you. Because I just did it. You automatically typed in the 10? Because see, I just didn't, and it didn't matter. So maybe your calculator was having a bad weekend. Okay, so log of 50. See, it put the 10 in there for me this time. What is log of 50? 1.7. And then what is log of 100? Wait, time out! I know you already said it, but can we think about it for just a second? If we use our properties from last week that we talked about, if I wrote this in exponential form, it would be 10 to the x power equals 100, right? 10 to what power equals 100? 2? Right? Now, if we checked it on our calculator, I promise it'll say 2, and quite a few of you already have, and that's good. Okay? So let me zoom back out for a second so we can fill in this paper. All right, so first thing I want you to do is I want you to evaluate 5,000 for me. Log of 5,000, and tell me what it is, and we're going to work from there. So what is log of 5,000? 3.7. Okay. Please rewrite log of 5,000 for me in terms of 5, 50, and 100. Oh, good. Good job. Log of 50 times 100. Isn't that the same as log of 5,000? Yeah. Yes? Okay, come over here on this side and let's rewrite this in terms of 0.7, 1.7, and 2. What is the log of 50? 1.7. And what is the log of 100? 2. Huh. So the log of 50 is 1.7. The log of 100 is 2. But the log of 5,000 is 3.7. Huh. I could add those to get 3.7, right? Okay. So somebody tell me what the log of 500 is then, please. 2.7? Okay. Then please rewrite that for me in terms of 5, 50, and 100. Log of 5 times 100, right? Isn't that the same as log of 500? Okay. How could I write 2.7 in terms of 0.7, 1.7, and 2? 0.7 plus 2? Huh. What's the log of 5 again? 0.7. What's the log of 100? Huh. Interesting. Okay. So what's the log of 250? 2.4. Log of 250 would be 5 times 50, right? If I was writing 2.4 in terms of 0.7, 1.7, and 2, wouldn't that be 0.7 plus 1.7? What's the log of 0.5? 0.7. And what's the log of 50? 1.7. So what about log of 20? How could I rewrite that in terms of 5, 50, and 100? Log of 100 divided by 5, right? What is the log of 20? Somebody tell me. 1.3? How could I rewrite 1.3 in terms of these three numbers? 2 minus 0.7? Wait, what is the log of 100? 2, and what's the log of 5? Oh my goodness. How do I rewrite log of 2? Or I guess I should say first, what is the log of 2? 0.3. Thank you. Now, how do I rewrite it in terms of 5, 50, and 100? Log of 100 divided by 50. How do I rewrite 0.3 in terms of 0.7, 1.7, and 2? 2 minus 1.7. What's the log of 100? 2. What's the log of 50? What is log of 10? So log of 50 divided by 5. How could I rewrite 1 using these three? 1.7 minus 0.7. What's the log of 50? 1.7. What's the log of 5? What patterns do occur and what rules can you develop? log of a product is, if we're taking the log of a product, what is that? The sum of each log. Do I need to write the word logarithm out for you, or can you understand what I mean by log? I don't actually mean like a tree log. No, I don't. So, do you see any other patterns besides that one? Log of a something, yeah, quotient would be better, is the what? The difference of each log? Yes? Okay. Look for patterns in the table below. Ooh, more patterns. See, if I give you formulas, you're just like, oh, I hate formulas. But if you figure out the formula yourself because of patterns, then you feel like a genius. Partially because you are, because not everybody can see patterns. Okay? So, log of 5 squared, doesn't that equal the log of 25? What is the log of 25? Okay, time out. She's not the only one with a calculator. Everyone else should be putting in log of 25. 1.4. How does this answer compare with the log of 5? Which is 0.7. Double? Okay. What about log of 5 to the third, which is the log of 125? 2.1. How does that compare to the log of 5? Triple? So for double, couldn't we say that it's times 2? Or times 3 for triple? Okay. What about the log of 625, which is 5 to the fourth? 2.8. How does that compare to 0.7? So times 4. What about log of 5 to the fifth, which is the log of 3,125? 3.5. How does that compare to 0.7? Times 5. Times 5. And what about log of 5 to the sixth power, which is log of 15,625? 4.2. And how does that compare? Anybody see any patterns? Multiply the exponent by the original value. Okay. Multiply the exponent. Which exponent do you mean? So like right here. Multiply that exponent. So wait, you're like bringing that down in front like a multiplier? Is that what you're telling me? Okay. So that's becoming, the exponent is becoming a multiplier. So then all that's left is the original value, the original log. Is that what you meant by the original log? What did I do? Oh. This is different. This is different. It's different. Yeah. We'll talk about that later. Okay? You got this? Log. Logarithm. So now let's talk about the actual properties. What the actual math stuff looks like. Okay? If it says log base b of x times y, how can we rewrite this? Log base b of x. What'd we do? Yeah, we add, right? The log base b of y. The log of a product is equal to the sum of the logs of the arguments. The log of a product, the log of two things being multiplied together, is equal to the sum, I'm adding, of the log of the arguments. Does that make sense? It's a vocabulary thing, guys, right now, so I need to make sure you're understanding the vocabulary. Are you with me? Excellent. So what about the second property right here? Log base b of x over y. Log base b of x minus log base b of y. But there's something else for us to fill in, isn't there? The log of a quotient is equal to the difference. Okay? So the log of a quotient is equal to the difference of the logs of the arguments. What about this last one? P log base b of x. The log of a number raised to a power is the same as the power times the log of the argument. Okay? Now, these last two properties are special rules, and I would actually like to talk about this bottom one first. Because, what did we just decide would happen to this p? It would go in front of the log as a multiplier, right? And then it would leave log base b of b, which is what we're going to figure out right here. So wouldn't it be more helpful to know this first and then go there? I think it will be, so we'll just go with what I think. Most of you thought that same way too, so it's fine. If you didn't think that way, shh. Okay? If I took log base 2 of 2 equals x and rewrote it in exponential form, I would get 2 raised to the x power equals 2. The base to the power equals the argument, right? So I get 2 to the x equals 2. Well, once the bases are the same, how do I figure out the exponents? I set them equal, right? Well, in this case, I get x equals 1. Will it always be x equal 1? Well, what if b was 5? Log base 5 of 5 equals x. So 5 to the x power equals 5. What if it was 23? Log base 23 of 23 equals x. 23 to the x power equals 23. Always 1. Well, you just told me a second ago this p would come down in front as a multiplier, and I'd get p times log base b of b. Right? Well, don't we know log base b of b? It's 1. So it's 1 times p. P. It's the same. Yeah. Any questions? Ask me. Huh? Because this value right here, log base b of b, is what we just figured out right here was a value of 1. So if I have a p out here in front, right here, p times 1 equals p. Yes. And that's a trick that some people use. They think if the base and the argument are the same, the answer is the exponent. But doesn't it work for this one too? If the base and the argument are the same, isn't the answer the exponent? A 1? Okay? So let's do some problems together to see if we understand this. One person is not allowed to answer all the answers. Shut up. Try these first without a calculator. It says then you can use a calculator to check if you want to, but we are smart. And so we are going to use the calculator to check because we are smart. Okay? So what are we doing with these two numbers, the arguments, to get the new argument? We are multiplying, so what do we need to do with these two numbers? Add them. What do you get? 2.95. So somebody in their calculator, please do log of 900. It's 2.95, isn't it? Good. Okay, so what are we doing with these two arguments to get this new argument? Multiplying, so what do we do with these two numbers? Add them. What do you get? 1.82. Okay. What are we doing with these two numbers to get this new argument? Dividing, so what do we do with these two numbers? And you get 1.1. Excellent. All right, there's only one. How do you get from here to here? Square it. So if I'm doing that, what do I do with that 2? It becomes a multiplier. So what is 2 times 1.04? Because to get from 11 to 121, you're squaring it. So the 2 becomes down in front as a multiplier. So it's 2 times 1.04. Are you lying? Rewrite each logarithm as a single expression. Log of 2 plus log of 5. Log. What do I do with these two numbers? Multiply. Log of 10. Done. What do I do with these two arguments? Divide them, so log of 100. What do I do with these two numbers? What do I do with them? Divide. So I have log base 5 of x over 10. Done. It's not asking us to solve it. Not yet. It's just asking us to rewrite it. Okay? What do I do here? What do I do with this 2? Make it an exponent. So first of all, I get log base 3 of x plus 1 squared, but I can go further. Log base 3 of x squared plus 2x plus 1. Where in the world did that come from? X plus 1 times x plus 1. Distribute, 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 distribute. Okay? So what about I? The 3 becomes an exponent. Don't be tricked. Don't be tricked. Don't be tricked. Remember, I ask you not to be tricked. I think 4 times now. Thank you. Log 8m to the 12th. What have other people said? 6 or 2, right? And then some of them say m to the 7th. You got to remember your exponent rules even when we're doing logarithms. Doesn't it help though? Don't these relate back to our exponent rules? If we're multiplying like bases, what do we do with the exponents? Add them. If we're adding like logarithms, what do you do with the arguments? Multiply. Oh my gosh. It's like the inverse operation. Oh my gosh. Okay, simplify each expression. These are using some of our special rules. You shouldn't care what 5 to the 7th is. Because if the base and the argument are the same, what's the answer? 7. When the base and the argument are the same, the answer is the exponent, which is 1. What about L? But there's no base. Oh, it's automatically 10? Okay, I just know. Sorry about that. What about M? Log base 12 of 12, so it's 1. Okay? Any questions? These are practice problems on the back. These are related, similar to the ones we just did, but some of them are more difficult. Because that's what they always do to you, right? They give you the easy ones when you're with me, and the harder ones when you're by yourself. Well, you're not by yourself. You have to the end of the period. Okay? Whatever you don't get finished by the end of the period is homework. But finish this before the end of the period, and then you're home free. Okay? Any questions?